So, on number 8, I'm going to walk through this, but you really already did it yesterday. So copy it now if you would like, but you could also just refer to that problem. So it told you to change this to sine x over cosine x. So if you take the derivative of that, you must use quotient rule, right? So that would be cosine of x times the derivative of sine x, which is also cosine x, minus sine x times the derivative of cosine x, which is negative sine x. Make sure you use those parentheses there, because if you don't, you're going to have minus sine x, and it won't look like they're multiplied, but they are, all over cosine squared x. Okay, what is cosine x times cosine x? Cosine squared x. What is negative sine x times negative sine x? Positive sine squared x over cosine squared x. What can we do next? Okay, cosine squared plus sine squared is 1. And what is 1 over cosine squared x? Secant squared x. So, now that we have done this once, we can commit this to memory. So, we can say the derivative of tangent x is always going to equal secant squared x. And we can just memorize this. Now, I wanted to show you how to find it without memorizing it, because sometimes we forget things that we thought we had memorized, right? So, so you've got the tools to figure it out if you forgot it. But for these other 4 trig functions, we do want to memorize these. These are ones that we want. If we see derivative of tangent x, we can just say it's secant squared. You don't have to go through the long process for it. So I want you guys to do this for the other 3. You didn't have to do any of those on. Did you have to do any of those on the worksheet? Did you already do cosecant? So since, let's see, which one was cosecant? Let me look at it. 17. Yeah, 17 you did cosecant. So let's just write that one down, because you should have already done it. So cosecant for that one, the derivative of cosecant x should just be negative cosecant x cotangent x. Right? So we just can memorize that one, right? Or if you get stuck and can't remember it, then you could always make it 1 over sine and work it out. Let's split you guys in half right here and have some of you guys do example 2 and some of you do example 3. So let's just, let's do U7 right here. Everybody on this side except for Webb. You guys do example 2. Webb and the other side of the room, you guys do example 3. Okay? So you'll need to use quotient rule. You'll need to change it to a fraction first, and then you can use quotient rule to take that derivative. Yeah, so over here, you guys are doing 2. This side and Webb, you guys are doing 3. And I'm going to freeze this so you can't see my work. Yes.
We did a lot. Really high was great. Yeah, but also it just makes us almost close to
I hope you get paid better than my cousins used to. My grandpa he's still alive, he's 97. And when my cousins were teenagers, he would pay them $4 an hour to pack lumber in the sawmill. It's not easy work. That was also not legal. It was minimum wage was still 75 or 25 or whatever it is now. So, but he's an old man who thought that was too much money to pay some teenager. Uh-huh. Yeah. Yeah. Mm-hmm.
Thank you, Joshua.
All right. Okay, over here, what did you guys get? Negative cosecant squared x. Okay, I agree. Over here, what did you guys get? Okay, very good. Secant x, tan x. Now I'll put this up here. Although I did write mine tangent x, secant x. I think, though, it is more common to see it secant x, tangent x. So I'm going to rewrite what I have here. So the process is very similar for each one of these. Let me zoom out just a little bit so that you can kind of see what I did, but you don't have to have the whole process written down unless you just really want it. What you really need to have are these different things that I have in the boxes here, because we can just memorize these and we don't have to show any work for doing them anymore. I will say they don't get used a lot, so a lot of times it's easy to forget them because they don't show up all that often. Sine and cosine, you'll have to take derivatives of them a lot. These functions do show up. They love to throw one or two on the exam to make sure you're paying attention, but you're not going to see them in lots of problems. There. So, if we see a problem like this, right here, so we just have, for example 5, f of x equals cosecant x over x. We could change cosecant to 1 over sine if we wanted to. That would work. But if we just know that the derivative of cosecant x is negative cosecant x cotangent x, right, because we just found that earlier, then we can use that piece to find this derivative. However, what else am I going to have to use besides just that piece right there? I got to use a quotient rule because I am dividing here. So I can't just do like negative cosecant x cotangent x over 1. I can't just take the derivative of the top and the bottom. When I've got a fraction like that with variables in both sides, I've got to use the quotient rule. So I would have f prime of x would be low times the derivative of the high, which is where we use this negative cosecant x cotangent x, minus high cosecant x times the derivative of the low, which is just the bottom, is just 1. And then we got over x squared. And so this would give us negative x cosecant x cotangent x minus cosecant x all over x squared. One thing I think they probably would do on this is I think they would factor out a negative cosecant x like this, and that would give you a cotangent x plus 1 right here. And there is a decent chance they'll write it this way. Because there was a cosecant there, and we're taking it out, there's nothing left, but we have to put a 1 there as a placeholder, so whenever we multiply it back. And you're factoring out the negative also, so it changes to a positive. That's right. I just haven't written it yet. It is going to reappear as a different thing. It is going to be like that.
Why is it that we put that on the bottom? I saw that on the homework last time, on like the one I took a picture of. Why do we move that to the bottom?
There is no rule that says that you have to do that. They just do that things like that sometimes. So that's just like one of those things. One of the reasons like I like that worksheet that I gave you, because if you don't, like, there is nothing wrong with this answer, really. Usually you would never see it left like this, because it'd be cleaned up just a little bit by like multiplying this stuff together. But there is nothing wrong with this answer right here. If it is free response, I would definitely just stop right there. There's no benefit to simplifying it further. But if it is multiple choice, they usually simplify it further. How they decided to simplify, there is no like specific set of rules of how they do that. So in some cases, even on the AP exam, they would leave it right here, where that cosecant has been factored out. But just because they can, I guess, sometimes they'll make it 1 over sine x, and then that sine x ends up in the bottom, right there. So there's the only like way to know how to leave your answer is if it's multiple choice, or if there's like an answer key you're checking your answer by.
So how does it just automatically get, like, how can it say that? I know, but like then it's in the numerator, so how is it just up here at the bottom?
So if we change it to 1 over, well, we got, I'm just going to kind of like pull that negative can, this stuff's multiplied, right? So that negative can kind of go out here. 1 over sine x, and it's multiplied by this stuff right here. Now, if it was added, it would be a different story. We'd have to do common denominators. But since it's multiplied, like you're just kind of putting this stuff over 1, you got cosine x plus 1 over sine x, and then you have to multiply it by 1 over x squared, like that.
So like I just hadn't
Yeah.
seen it like that, and I hadn't seen it last night. It was like
Yeah. As long as it is multiplied and not added or subtracted, you can kind of just do, like, change that cosecant to 1 over sine x and put it in the bottom. As long as you have multiplication between it and whatever else is over there. If it's addition or subtraction, you can't do that. Like, I would not be able to do that with a cotangent. I couldn't just, like, make tangent a sine on top and a cosine on bottom. Or, well, actually, opposites cotangent. So, but with the cosecant, I can because it's multiplied. Yeah. All right. We're going to do one more. All right. So, let's look at this one. We've got 1 over x plus e to the x tangent x. So we've got a lot of stuff going on here. We've got 1 over x, and then we've got an e to the x times tangent x. For this first part, what are we going to have to do here? I can. What do I need to do to take that derivative? I could use quotient rule. But it will be easier if we just rewrite this and make it x to the negative 1 power plus e to the x tangent x. So quotient rule will work right there, but because the numerator is just a number, it's not got a variable or anything that would complicate it for us. If I rewrite it as a negative exponent, then I just have to use power rule on that part. But what am I going to have to use on the e to the x tangent x? That has to be a product rule because you've got two things that both have variables that are being multiplied together. So for our derivative, we would have negative 1 x to the negative 2 for that first part, just straight power rule. Then we would have to do our product rule, so that would be e to the x times the derivative of tangent x, which we just did and put in a box earlier. And what was it? Secant squared x plus tangent x times the derivative of e to the x. What is that? E to the x. It's the easiest derivative that we'll do. And so they might leave it with negative exponents. They might make this negative 1 over x squared. It just depends. There's really not a lot you can do over here. They're just going to clean it up a little bit. Like this, probably. Not really much you can do to simplify that. The biggest mistake I see kids make most of the time is that they don't use product rule. They just like take the derivative of each piece. Like they'll just say derivative of e to the x is e to the x, derivative of tangent secant squared x, and they'll leave that as the answer. So just make sure when you see two things multiplied that both have variable parts, you've got to use the product rule for that. Okay, questions? All right, we're in good shape today. All right, so let's see here. All right, so your assignment for tonight is page 154, 45 to 48, 50, 51, 53. Okay, this is not much. Hopefully you can get it done before you go. I would suggest going ahead and starting on some of the progress check stuff tomorrow, because there are two parts of multiple choice, and then it's got two parts of the free response, but it's 3 free response questions. We will not be able to get all of that done in class tomorrow. So since you should hopefully get this done before you leave, I would work on some progress check stuff tonight too, so that you don't have too much Thursday night.
So is it only FRQ stuff on the progress check or FRQ?
It's both. There's like on AP Classroom, there's 4 sections that you have to do. So there's 2 that are multiple choice and 2 that are free response. Multiple choice, obviously, just answer those there. The free response, make sure that you write those on paper for me. But those won't be due till Friday. And that's what we'll work on in class tomorrow.